to do that, first we have to define some variables. First, we have to find force, which we're going to use a formula, which I'll mention later. And in that formula, we need the gravitational constant. So in line 3, we define the gravitational constant as 6.67 times 10 to the negative 11th. And in line 4, we have dr, which is our Death Star radius in meters. ds, the next line, is Death Star mass in kilograms. mf, the next line, is Millennium Falcon mass in kilograms. And then our force net vector at our original position is 0, 0. So in line 10, you can see that's our position vector for the Falcon. That's our initial position that the Falcon is at. In line 12, this vector defines the initial velocity of the Millennium Falcon, and in the next line, that formula is the initial momentum of the Millennium Falcon. Since p equals mv, you can see that the Falcon momentum is equal to mf, which we defined as the Millennium Falcon mass in kilograms times the Falcon velocity. So in the program, once I run it, you can see that there's going to be two arrows. The first arrow is going to be green, and that is this basically shows the force. The second arrow is white, and this one shows the position. So next, we had to define our dt, which dt equals delta t, or change in time. And I chose that as 8 because a little bit less would have been too slow, a little bit more would have been too fast. And below that, there's the equation Rmag is equal to mag times falcon.pos. This basically means that this is the formula for the calculation of distance from the Millennium Falcon to the Death Star. In line 22, we can see that it says while Rmag is greater than dr. Now, if I had changed that around, it would have caused the Millennium Falcon to crash into the Death Star, which would not have been good for Hans and Luke. So the magnitude of r had to be greater than dr, which is our Death Star radius in meters. We defined our rate, and in line 24, we defined our Falcon position as r. So then with r, we use it to find r magnitude, the magnitude of the position, and then r hat, which eventually led to this important formula of the gravity is equal to our constant g times our masses, and this is negative, all divided by r mag squared times r hat. So further down, we can see in line 37 what really helps us calculate the force. And this is if falcon.pos.y is less than equals 0. So if I had just left it without the y, it wouldn't have calculated it at the closest position. By entering y, I was able to calculate the force between the Death Star and the Millennium Falcon at the closest point between the two. And then by doing that, I was able to print fnet, which basically means I can find the position, and brake because I only wanted it once. I didn't want the Millennium Falcon to circle the Death Star too much, or they could be recognized by Darth Vader and be killed. So once I run this program, you can see the green arrow, like I mentioned before, is our fnet arrow, and then our white arrow is the Falcon position, and they're exactly at a 90-degree angle. And here, if we zoom in, we can see that it's very close. The Millennium Falcon, which would be here, is very close to the Death Star, and this would be its closest point, making our force negative 64,436.8, negative 436.371, 0. And that's the end.